pull off on me.
Hello, everybody. Thank you for coming. Today, we're going to be talking about designing REST APIs. My name is Andrew. I was a product manager at Twilio for about 5.5 years and spent a lot of time developing REST APIs, specifically developing REST APIs to be consumed by external clients, but also worked on a team where everything we built was a REST API, and our clients were either our customers or the other teams who needed to consume data from our services. But for purpose of today, we're going to be talking about mostly building REST APIs to be consumed by people you're trying to make money from. If you want slides as we go along, a lot easier than just kind of taking your phone out and taking a photo of a slide. The whole deck is here in PDF if you want to download it to follow along. Like I said, it will also be published afterwards. So kind of what are we going to talk about? This is going to be fairly fast, and talking to a lot of you, I was really excited. A lot of you are already building and consuming REST APIs in your day-to-day jobs and have a lot of interesting questions. So this is going to be pretty high level, but would love to dig into some of the kind of gnarlier, deeper things afterwards. So we're going to talk about kind of API as a business model. What does that mean? We're going to talk about API flavors. How do you determine the flavor of your API, and what does that mean? Strawberry is a good one. We're going to talk about resource design. So once you have a flavor for your API, what do you do with it? You have you know what it's supposed to be, and how do you make it useful? We're going to talk about testing and feedback. So this is super tricky with REST APIs, but there's some things you can do to make it easier. And then at the end, there's a nice slide for all the talks from people I found really useful about API design that hopefully you guys can piggyback on those and kind of get deeper. So fundamentally, what is an API? If you're building an API strategy, what are you doing? You're building an API because you're building a service that does something useful. And that useful thing is probably fairly complex and messy, but it's really, really useful. And you want to make it's so your client, that might be another group of developers at your company, this may be someone you're trying to sell something to, they want to consume that thing and they want it to be really easy and simple. And you can build a really, really good business doing this effectively. So Shippo, Twilio, and Stripe have all done a really good job building kind of an API first and API only business model. And what they're doing is fundamentally taking something really tricky, wrapping it in a really nice clean interface, and then selling it to people to consume really easily. So for instance, Shippo takes the process of shipping a package from one place to another. There are a million different permutations in how to effectively send a package based on what carrier to use, local carriers, international aggregators, what business deal do you have with them, what are your discounts, a million different ways to do this effectively. Shippo reduces it to provide the details of your package, get shipping label. Underneath, there's a lot of really complex things that happen that allow you to get a really good rate on sending a package from A to B really quickly. So they reduce kind of this really, really tricky problem to press button, get label. Twilio does the same thing for a variety of communications mediums, voice, SMS, video, a ton of other things as well, faxes, telegrams. And they've reduced sending an SMS is a good example anywhere in the world, which is a really complicated problem with interconnecting with carriers all over the world, handling carrier encodings, just in general, a lot of complexity. They've reduced that down to send HTTP request and an SMS shows up somewhere in the world. And Stripe, who's actually, I realize now, just across the hall, has done something really similar with payments. There are many different payment modalities. There are many different currencies to worry about, recurring subscriptions. There's a lot of complexity there, and they've reduced collecting payment from your customers to submit API request, get money. Always a popular one. So a little bit about Twilio. Twilio's fundamental product strategy is solve hard problems for which customers will pay you. Two important things there. One, solve hard problems. Hard problems are harder for your competitors to duplicate. Focusing on easy problems gets you replicated really quickly. And willingness to pay. There are lots of very interesting technical problems you could be solving. There are lots of ones people will not pay you for. Those are the worst problems to solve. Don't solve those ones. Twilio was founded in 2007, API only, And recently in 2016, IPO'd for $2.8 billion. So it's a very, very viable business model in selling APIs to customers and to like large enterprises and startups, like the entire gamut. A little bit about myself. I was the product manager for the voice team at Twilio. The teams I worked with served over 100 million API requests a day. Our business, when I left, was running at over 100 million annually. And we were doing so with like pretty regular consistency. So we were at 5 nines of uptime and a 5.9 success rate. So it's all about building APIs that would scale and also would be robust. So to start, we're going to talk about API flavors. So the flavor is kind of like the wrapper that goes around your API that helps people understand your APIs from like different endpoints. All right. Yeah. I can just click through. It's fine. Cool. So defining your API flavor. So this is one of the core values in an API is consistency, where if a user uses your API in one place, they can go and use it in some other place, and they kind of generally understand how it's going to work. That kind of consistency comes from planning up front and determining like the flavor of your API. So what do I mean by flavor? The first flavor thing is like choosing which HTTP methods you're going to support. Like REST allows you to support a lot of potential methods, but like honestly, no one understands what patch does, and put's a little iffy too. So like figuring out exactly which ones you're going to support and then being consistent about it throughout your API is really, really useful and helps developers kind of be able to predict what you're going to do next. Choosing the data interchanges formats you're going to both send and accept. Like there's no right way to do this. You can send post parameters, you can send JSON, you can send XML, YAML, some format you invented, and you can get back the same format or you can get back a different format. Like there's no right way to do this, but just pick one way, communicate it well to your developers, and then stick to that one way. For formats for dates and times, I've learned a lot of very painful lessons about this. There is only one right way, like just do ISO 8061 and do UTC, and you will have a much better time. If I were going to go back and redo one thing about our stack, it would be to only do that everywhere, and it would save thousands of hours down the road. And also define what your default fields are. So figure out like for every response, there's always going to be something that your developer can depend on being there, and they can like write their client to always expect those fields. And like the sum of these decisions makes up your API flavor. And the best way to kind of get acquainted with API flavors is to like go and look at the APIs for some of the common companies. Go look at 18F has a really good API specification guide. Go look at Stripe's API. Go look at Twilio's. And like kind of get an idea of like the design decisions they made and understand if they make sense for what your clients want or if you want something slightly different. But no matter what you do, pick one thing, be consistent about it, and communicate it to your developers. So I'm going to talk about kind of a flavored, an example of like a flavored API. So this is what I'm very familiar with. This is a Twilio flavored API. And a Twilio flavored API is a REST API that accepts URL encoded post parameters and returns either JSON or XML. For this, we're going to say it's going to return JSON. And I've made a bunch of like decisions about this API, and I'll kind of walk you through them. So this example is shown using curl. I think it's incredibly important when you're designing APIs that to allow your developer to, at least for test data, curl at them. Like making your APIs really easy to use without having to like have your developer learn like a complex authentication mechanism or require them to use your client library makes discovery and understanding of APIs really straightforward. So post, we've determined that if we made our first decision that if you're going to create a new object on an endpoint, post is going to be the object, going to be the method for creation. So in this example, I've created a fictional REST API for the family for talks. So this is an API that has a list of all the talks that have ever been given on the family. So I'm going to add, in this request, I'm adding my talk to this API. So I'm going to post to api.family.co/v1. So v1, this is a version slug. This is how hopefully you will never have to version your API. Unfortunately, you probably will. And if you do have to do this, having thought out how you're going to handle versioning from the beginning will make your life a lot better. In this case, this is the first version of the API, and we're going to include a version slug in the path. And then talks. So talks is the resource. This is like the thing that the API is useful for. This API is accepts new talks, and then later you'll be able to read talks out of it. You might want to do this, say the family is building a mobile app, and that mobile app is going to have a little thing. We can like click on a tab that says talks, and you want to be able to like scroll through all the talks. Building this API would make it really easy for a mobile client or any other client to consume a list of talks that have been given at the family. Then we're going to pass in some data. So we're going to pass in my speaker, or my name as a speaker. We're going to pass in a topic, and then we're going to authenticate to the API. This is a subject for which we could spend another half an hour talking about. In this case, we're going to use basic auth because I think it's really, really important to make your API super easy to use and kind of a good first user experience. There are many other ways to authenticate. We've gotten through, or at Twilio, we've gotten through like Fortune 10 company security reviews using basic auth. As long as you have like a key management system and you can tell a story behind it, it will be fine. But you could have another talk there. And lastly, the content type. So this tells the server what type of content is coming, and this is what makes it kind of Twilio flavored, where we're sending in post parameters and we're expecting JSON out back. Then we have the response, and here is a couple more design decisions, so kind of required fields. We're returning a globally unique user identifier for every new object we create. This is incredibly useful, kind of two things about this that are super useful. One, globally unique makes it infinitely more supportable. If your support team can take a GUID, plug it into, hopefully you have tooling so your support team can look at objects, plug it in and like see that object without having to know kind of like whose account it's on is incredibly useful. Globally unique is also important because that means the IDs are non-sequential. Having non-sequential identifiers for your resources is really important. We were able to do competitive research on one of our customers because they had sequential identifiers for their objects. So we could go like at the beginning of the month, we could send one message, we got back the user ID or the message ID. We waited till the end of the month, sent another message. Got the user ID, calculated the distance between the two. Now we know the run rate for our competitor. So for security and also for supportability of your system, making the user IDs globally unique and non-sequential is really important. Date created, talked about this earlier. Pick one date format, stick to it. Speaker name, this is actually the content of the object. And then you have all like the hypermedia things. So REST APIs are supposed to be stateless, where the client shouldn't need to know anything about the structure of your API in order to navigate it. In order to do that, providing the URI for this object and also the URI to any sub-objects in every single request allows your client to do that. Whether anyone actually uses these in practice to like have their client navigate through your API is up for debate, but it's good practice to do so. Cool. So now you've kind of determined the flavor of your API and you've seen like one sample endpoint. Let's talk about kind of the core value of an API and why people buy APIs and why people decide to migrate off API providers. There's this discussion, or this like in API circles, there's this kind of repeating cadence that APIs are contracts. That once you publish a public API, that is your contract with a developer and you shall not modify it. Because it kind of destroys the niceness of an API. Like you don't want to enter into a business contract where you say, you press this button and I will send a text message for you. And you agree that this is like, and for that you will pay me 4 cents. That is like kind of the contract. And you encode that contract into the API that you deliver to your customer. And then 8 months later, you decide that, actually that button which sent SMS is now going to place calls. Like, not only have you fundamentally changed like the business model that where you're operating with, but you've broken any of your customers who are expecting that button to send text messages. So it's critically important that once you ship an API and declare it like, GA, this is the, golden, done, complete API, that you do not change it unless you have really, really good reason to. And we'll talk about kind of what a really good reason is and how you handle that later. But above all else, predictability. And predictability is kind of what makes an API nice to use. When a developer says an API is nice to use, what they mean is I learned how to use one part of it, and then I went to go look at another part, and I intuitively understood how that other part works because you designed it in a predictable manner. What a product manager says when they say an API is nice to use is it only took 2 sprints or like a sprint or a day for my engineer to integrate this. It was easy to integrate. And what a business user means when they say that an API is nice to use is we integrated it once, forgot about it, and it's still there 3 years doing the same thing. And all this predictability comes from a really disciplined design process. If you guys are familiar with agile development, there's kind of an inherent contradiction between designing really good APIs and doing so with an agile process. Or it seems like an inherent contradiction. And that's because once you publish an API and it's GA, you shouldn't change it. So then how do you iterate? How do you gather user feedback? Like, how do you make the product better? The answer is very, very carefully and by front-loading a lot of the planning. So this is kind of how I think about the cost of API development and when you need to make your hard decisions. The more planning you do up front, the easier time you're going to have. The cost for changes for an API are relatively low as long as you have no users or all your users are internal. Once you actually have users in production and you need to make a breaking change, your costs become astronomically high. You may end up, building, maintaining, documenting, and supporting 2 parallel versions of a very similar API. Like your documentation overhead just doubled, your engineering overhead just doubled, and now you need to train every support person on 2 versions of an API. So you've effectively doubled the work you'll need to do to make any change. In order to avoid this, the planning has to be front-loaded. So this is very product managery stuff in terms of how you determine what API to build. But I think one of the key differentiators for designing APIs is that it's kind of like meta product management. You have 2 customers in mind. The first customer is the person who's actually going to be consuming your API. So this is the developer, right? And that developer wants it to be easy to understand. They want it to be simple. They want it to be powerful, and they want it to work. But that developer also isn't the only person you need to think about. You need to think about who that developer's customer is. What are they trying to build? And what is that thing trying to accomplish, and what is that person's requirements? So if you have the easiest, to use API, but the developer is trying to use it for a healthcare company, right? And that healthcare company has really strict security requirements, and you can't meet the security requirements. It's good for the developer, they like it, but you're never going to actually sell that product. So you kind of need to practices like meta product management, where you need to think about interviewing not only the developer who you're going to be selling to or that developer's product manager, but also asking that product manager, who are your customers? What do they care about? What are they trying to build? What products are you actually shipping using my APIs? And this is kind of old-fashioned, and Twilio got started before there were a lot of the API definition tools that exist now, before Swagger, before a lot of this stuff. And so the primary tool we use for designing APIs is Google Docs. It's quite sophisticated. We have tables. But I think this is it's a really effective process because it forces you to do a lot of the thinking before you do a lot of the writing out endpoints and methods and parameters and figuring out how are, what does it look like, and what is the rate limiting, and all these, what is the authentication mechanism. It forces you to really think about what is the core problem you're trying to solve. Is it worth solving, and can you solve it with the systems that you're trying to abstract? Do you have within your software stack the capability of solving this problem, and should you even try stretching that capability to make an API? And this is where we've teased out a lot of design issues early on in the process by writing a narrative, we're talking 8 or 9 pages about what is this API, who is the customer, what are the quotes from this customer about what they're trying to do, what do they care about, what is our pricing philosophy on this API. And then from there, like writing that out and then sitting down with engineering, with your engineering leads and say, okay, here's what we're trying to accomplish. Tell me about what the underlying systems we have are that could accomplish this, and what are the, like, what's going to work, what's not going to work. And this is a really, really good chance to kind of save yourself time later by making sure there are no like roadblocks that you're going to encounter later. And also, this process loads a lot of context for your engineering teams. There are tons of tiny little decisions that an engineering team will need to make correctly in order to build like a good API. Like as a product manager, you can only specify so much, or you could try to specify every nth detail, and you'll take up all your time, and your engineers will hate it. But by this process of kind of sitting through and walking like the product and engineering teams through the narrative, everyone has the context and can make better independent decisions that end up in a better product delivered to the customer faster. So now that you're actually, you've defined your flavor, you've written out a narrative about what you're going to do, now it's time to actually define your resources. And this is a really tricky one where I was giving this talk. It's like, how do you tell people how to define a resource, right? Like you have data in your database, you have some services or microservices which do things. How do you coalesce those together into an object model that makes sense to your customer and is appropriately simple, but still encapsulating a lot of the power of kind of the underlying systems you have. This is like the art of API design. There's no like specific, there's no like general actionable advice. It's more like think really hard about the correct level of abstraction. And kind of like on one side of that, you have like everything in your database you just expose to your client directly. There's like no abstraction at all. You just say like whatever's in there, figure out how to chop it up into a REST API and serve it, all the way to boil it down to like the very narrowest possible feature set, and expose that to the customer. Somewhere in the middle is like the right thing for your client, and only by talking to your client and really understanding what they need will you arrive at the correct level of abstraction. I would say in general, start with the fewest things you can to still satisfy your client. You can always add things over time, but removing or changing things is quite costly. Perfect. So now this gets a little out of my realm. This is where I was very fortunate to work with some very strong engineering teams who actually handled the technical specification for the API. If I were doing this now, I would use Swagger. At the time, we have our own, at Twilio had our own API definition language that we'd written that does code generation and documentation generation, but it's Swagger-ish, so that's probably what I would use now. But if you've really done a good job defining your object model, this is kind of translation at this point, where you've taken your object model and you just need to figure out, like, we know what our objects are, what methods will they support, what sub-resources do they need to support, and then pushing that into whatever you're using to define your API. And then this is also kind of where, once that technical document is completed, hopefully you will have teased out most of the problems you may have with the API. And at that point, you'll end up with a completed technical document, and that'll feed back into your initial like narrative product spec. And that is kind of the seeds which will become your documentation. So you'll start with this narrative product documentation. That will be the first thing that you share with customers. So you'll take this and it'll provide a discussion point for you and your engineering team. It will also provide a document that you can then distill down into something you can share with your customers, so you can get like customer validation. And then after this technical specification comes back through, you can go through, revise those again, share it with customers, and that will be kind of what you take into testing. So when we discussed the kind of non-agile nature of API development, the way you make it agile is by being your own customer and doing as much validation internally as you can before you send your API out into the world. And as a product manager, I think it's pretty important, if you're designing APIs as a product manager, that you develop against your own APIs. Like you should own the API kind of end to end from inception to delivery. And you have like the clearest idea of who your customer is and what they want. And you should be able to take that, and if you can't develop against it, it makes it really hard for you to truly understand like what your API is and whether it's usable and whether it's responsive enough and whether if the rate limits make sense. So I highly recommend, take the time. I'm not a particularly strong software engineer, so this is something that's always very, very time consuming for me, but it's worth it every single time because you tease out a lot of things that you wouldn't otherwise found and find a lot of things that like just aren't quite right, but no one else would notice or no one else would really take the time to dig into something so early and unformed to understand whether what you're building is correct. Then we get an internal testing. The most effective internal testing tool I found is to run internal hackathons with your team. So generally you want this to be, if you are so fortunate as to have developer evangelists or technical marketers, they're really good to pull in because they have very little context about why you're doing what you're doing or why. So they're kind of a good like naive test subject. Bringing in obviously your development team and then just get anyone else who's willing to pitch in for the day. Write out a couple challenges, so kind of like what the happy path is for this API. You should be able to, like the family API, you should be able to build a mobile web view and then use this API to visualize a list of talks and say like that's one of the challenges. You should be able to write a talk, you should be able to delete a talk, and then set people loose on it and see if they're able to do the things you should be able to do with that API that you set out to do it. And if you can, you're in a pretty good spot. And then this is a good chance to tune up your documentation. So in that hackathon, you'll get rapid feedback from people on your team that like, this is unclear, I didn't understand how to do this thing, this formatting doesn't make sense. And that's a chance to really rapidly iterate on your documentation and get feedback while your clients are all still in the same room and telling you what doesn't work, as opposed to once you're in production and you're hearing about this through email and it's a much trickier process. External testing. So this is a really hard one, generally because the motivations of your customers are kind of orthogonal to your own. In a perfect world, you'd be able to launch a very early API. So you define like a couple stages for your API. You say, okay, once an API is public, there are 3 stages. There's, say, a preview stage where it's mostly fully formed but may break and operationally probably isn't super strong. There's a beta stage where it should be near production ready, and then there should be a GA stage where we say, this is ready, we will not change it, and we commit to it operating at a really reliable level. So for preview APIs, ideally your customers would jump in and be really excited about trying a new API. In practice, that's not really the case. Everyone has pretty finite developer resources. So like pitching a product manager on, hey, like would you love to tie up one of your engineers for a week to write integration against an API which will likely be totally irrelevant by the time you're done with it. Like it's not a great pitch. It's really, really hard to get someone to do that. And that's why you try to do a lot of the development internally first. What we generally find is that like the beta stage is where you can really start to reach out to customers and get feedback from them and like see if they like the API. So yeah, this is kind of the core conflict is customers only want to try your API once it's finished or nearly finished. They don't want to like waste a lot of time on something that's going to break. But if you never get customer feedback, it may never be finished and creates kind of a circular dependency. The best way to break out of this I found, hackathons are a really good opportunity for this. Just buy some Amazon cards or whatever you use to bribe in your local market and go to a hackathon. A lot of these people are pretty familiar with integrating against APIs and just offer people money to like build a sample integration against your API and tell you what you think. Like, is this easy to use? Is it hard to use? Was the documentation unclear? Really useful. It's good for rapid feedback. You can, in a day, you can, if you're at a big hackathon, you can do, 5, 10, 15 sittings and get a lot of good feedback. But the most important thing, especially if you're an established product, is pick 1 or 2 customers who are strong engineers and have like good sense about what makes a good API, and just treat them really, really well and kind of cultivate them as testers. So, these are the customers you keep very, very close, you treat very, very well. And they'll be incredibly valuable in helping you understand whether you're building the right thing or not. We haven't talked a lot about selling APIs, which is a whole other thing, but I think one of the really important things is when you start trying to sell an API, similar to the problem around testing an API, everyone has really blocked developer schedules. So if you wait until like your API is GA, you're like, great, it's done, it's ready, it's good to go for the world. Like sales team, take it, go sell it. And you start talking to customers, even if someone really, really wants your thing right now, it's super hard for them to drop everything else on their roadmap and start working on a feature that integrates your API. You need to telegraph, like, depending on the size of customer you're selling into, for startups, like maybe a month, maybe 2 months. For big corporates, might even be 6 months. Telegraph where you're going to go and start selling in the earlier phases so that by the time you're GA, they've already been planning to integrate it, in a quarter, and you can like shorten the time scale for adoption. Cool. So now you're fortunate enough to have made it to general availability. So you have this API out, this contract. It was perfectly designed. It never has to change. It just runs. It's great. Not actually how it works, but hopefully you're close. Once you're in GA, the biggest ongoing maintenance task is documentation. Your documentation is never really done and never really good enough. People will find new and exciting ways to misunderstand your documentation all the time. And you need to like constantly be updating it and like working on onboarding materials, sample code. It can always be better. And if you're an API first company, the time that someone is spending trying to understand your API and not making requests is time you're not getting paid. So as much as you can shorten that as possible, you'll end up with much better returns. Fixing bugs, but not all of them. This is a really important irony of building APIs when things are contracts. Sometimes a bug is unintentionally part of the contract, so you need to be very, very thoughtful about the bugs you choose to fix and the bugs you choose not to fix. If a bug that has been present in the wild for quite a while represents like a well-established behavior of the API, it might be better to just change the documentation to say that's how it works, because you very likely will break someone who depends on that bug existing. So the older a bug is, the less likely it's a good idea to fix it, and maybe time to move the documentation to match the bug and not the other way around. And then lastly, gather feedback for future enhancements. Your API can always be better, and just make sure you're continually reaching out to customers. I try to do all of the customer support for any API that I push out into production for a while, just so you get like the raw customer feedback about what's good, what's bad, and how it can be better. So this is like the happy case, but generally, especially if you ship the V1 of anything, especially if you're still figuring out your business model, the V1 of your API will likely be fundamentally broken in some way you did not foresee. And this happened with Twilio's APIs, and we had to do a major version in 2008. Fortunately, haven't had to do a major version change since, but if you have to make changes, you want to do so carefully and very thoughtfully. I think one of the first things is, this has been a recurring theme throughout the talk, but communicate exactly how you're going to change your API to your customers. Nothing should be a surprise. If you're going to deprecate something, try not to, but like make sure it's extremely well communicated that either you will not deprecate, or you stand behind your APIs for 2 years, or if you deprecate, you will give 6 months notice. Whatever your policy is, make sure it's extremely well communicated with your customers. Also, the good news is additive changes are mostly safe. If you're going to add a new endpoint, add a new parameter to a resource, in general and in my experience, you generally don't break clients this way. So that gives you one degree of freedom when moving to change your APIs, and this is also a reason to start small. You can always add things later. Really hard to take things away. Yeah, so if you have to version your API, like I said earlier, this is like the horror of every API designer's life. Is like, okay, we have all these clients out in the wild. We now we realize we've done something terrible that's like either dangerous to our infrastructure, or the API we shipped was not useful, or something else, and you need to version your API. In that case, there's some things you should think about. One, so versioning strategy, make sure you have like a version slug in your URI. I think that's the preferred way to version. Some people like doing it in headers. I don't really think that's a great idea. I'd prefer to have it in the URI. like we talked about earlier, this will greatly increase the overall overhead for maintaining your API. So really try not to do it unless you can avoid it. And lastly, this is like everyone at Twilio who's like a newer PM, they'll see something wrong with like an old API and say like, well, we'll just deprecate that and move everyone off it. Like, this is just never going to happen. There is always, if you do integrations with customers, you know, as a product manager, you think that people like really care about your API, that they're happy to use it, that they understand what it is. In practice, if you built an API well, it was integrated by like a contractor at some company 4 years ago. No one knows what it is. No one remembers what it is, nor could change it if they wanted to. So be prepared to support things for the long haul. Because if you really have to deprecate an API and you have to shut it down for whatever reason, you will invariably break some customers, and you need to be comfortable that you're going to piss off like a decent number of people in that. And that, you know, as many deprecation emails as you send out that we're going to shut this down and people should migrate, there are some people who will never go those emails. You eventually break someone, and if you've built something really good that's really core to someone's business, you know, you could bring their business to a standstill. So be very thoughtful about versioning, and probably if you're building something business critical, you should assume that your endpoints will be around forever, or for at least for the life of your company. Cool. So takeaways, these are a bunch of things that you'll get out of the slides. Don't try to read them all now. But just in general, like pick an API flavor. Just do ISO 8601, please, just for me. HTTPS only and always. Yep. So in terms of resources, this was a really short talk. There are like hour-long talks you could do on any one of kind of the slides we talked about, and these people have. So I'd highly recommend all of these. Once again, like once you get them out of the deck, highly recommend following this. If you only do one thing here, watch this talk by Amanda. It's incredible. If you do two things, yeah, order them. Do this one. This one's really good. Perfect. Yeah, that's all I have for today. I would love to talk to any and all of you about your API-related questions, but for now, yeah, what can I answer?
Hey, my name is Chris Taylor. I'm a digital producer from Canada. I really liked your talk, by the way. Thank you very much. So I'm a product manager. I guess it's a little bit more open-ended as a digital producer because I do a lot of front-end stuff, but I've also done some, I've produced some APIs for front-end apps. And I'm wondering, so as a product owner, product/product manager, where do you feel like I could help when developing an API, and where do you think a lot of project managers have actually hindered the production of an API based on their abilities?
Yeah, I mean, that's, yeah, it's tricky to know kind of at what level you should be involved. I think it depends on the strength of your engineering team and how much you kind of trust their understanding of kind of the purpose of the API. And like, I think like, you know, the most helpful thing is to communicate vision and also like give your development team like filtered and what's the word? Like filtered user feedback. So like actual quotes from customers, like, you know, do all your user interviews, distill it down to kind of like just what you think is really important for your developers to hear, and make sure they get that. And if like that's the level you want to work at, then you can kind of give them that and get out of the way and then check back in to see what they're doing. But I think like over specification is kind of a really dangerous thing, because fundamentally as a product owner, like I don't understand all of the details of the underlying system we're trying to abstract. And so you rely on your engineers to make good choices about like the abstractions that they're creating, and kind of, you know, yeah, there's just like a million small details that they're going to have to figure out, and making sure they have adequate information to like make good choices there is really important. And kind of conversely, not trying to over specify when you don't actually understand the full detail of the underlying system, I think is really important.
Thank you.
Hey, Zian. So I'm a software engineer, and I want to know more details about how you guys are managing different versions of Twilio API, because actually we have this issue in the company last weeks. Is like we are in a situation where there is some of modification that we wanna apply to the API, but as you said, we saw some of issues. For example, if we create a totally different version in the URL, that means that will create other problems like manage different versions, and definitely that will break things for some of users.
Yep.
So we thought about something like using headers, but using headers that, of course, that help on managing different versions, but create like a lot of code, a lot of stuff. So if you would give me more details about an example.
Yeah. So the dirty secret I didn't mention about how we handle version or behavior changes is we have Twilio has a very robust system of flags, which change API behavior in subtle ways. And flags are generally rolled out one of two ways. So like a flag would do something like, say, in the early Twilio days, we were super US centric, and so we always returned phone numbers in like a US formatting, right? We didn't do E164 because we weren't thinking about the rest of the world, which was a thing we really should have thought about. And so we wanted to introduce a change where numbers would go from like kind of a local US formatting to E164 formatting. And the way we implemented that was by kind of picking like a point in time for users and saying, okay, so as part of our account creation process, from like this point in time forward, all users will have this flag on their account, and in the code path we'll check, and anytime we're going to return a date to them, we're going to check this flag, and depending on what the flag is, we'll render the phone number one way or the other. And so those flags are automatically applied at account creation from like one point forward for all new users, and then also can be manually applied by support or anyone who has access to the DB to change the behavior for individual customers. So it allows you to specify, to be more granular about who's seeing like behavior changes in the API without doing like a hard version change. It creates some problems. It makes testing really hard. It's something that you should always, like if you're introducing flags, you hope to phase them out over time. In practice, there are a lot of them. So yeah, that's one strategy we use to make like small behavior changes without branching off the API into a new version.
I wanted to know, what is your process of validating ideas and new features for the product market fit?
Yep.
Because as you said that once you build something in, it's hard to take out. So I'm a product manager as well and have been working a lot on apps. You can build features and you do A/B testing, you see if it works. If it doesn't, you just take it out. But obviously that doesn't work that easy for APIs.
Yeah, I mean, I think for us, it's we use the kind of like the phased release, kind of like preview, beta, GA. Like some things, if they don't work out, they just don't make it a GA. And we beta APIs don't have a guarantee that they will exist forever. And we say, this went out, we thought it was going to be really big, it never really got the traction that it deserved. And so we never really spent the engineering effort to kind of like solidify that API and like really do a lot of like the quality and reliability engineering behind it. And so you can because if they don't make it a GA, you can just kill them and say like, okay, this just didn't go and we can get rid of it. Validating ideas is super hard. I think that's where like you have to do a lot of that in kind of like upfront interviews with your customers and like internal validation. It's a really hard process. But I think kind of understanding, communicating to your customers that like some APIs we will release publicly, but will not exist forever, and some of them may get killed. Setting those expectations helps you be a little more experimental.
Thank you so much, Andrew. It was a great talk.
Que la famille.